Let's talk about inscribed angles. So here I have 3 inscribed angles, and these are the 3 different ways an angle can be inscribed in a circle. So the first way is with the center of the circle on the inside of the angle. So here's the angle, okay, and the center of the circle is on the inside. The second way is that the center of the circle is on the outside of the angle. So here's your inscribed angle, and there's your center of the circle. And then the third way to inscribe an angle in a circle is to have the center of the circle be on one of the sides of the angle. Okay? So why don't you pause the video, and given these 3 inscribed angles, try to come up with a definition of an inscribed angle. And then you can press resume and you'll hear mine. Okay, so what do we notice about these 3 angles? What do they have in common? Well, I can see right here that for all of the angles, the vertex of the angle is on the circle. Yeah, in every single case, the vertex of the angle is on the circle. And I also notice that the sides of the angle in every single case are chords of the circle. So in every case, the sides of the angle are chords of the circle. So let me try to write a definition here. Okay. So, again, let's look at what we've got here. So what I had said, so we'll call this the definition, okay, of an inscribed angle. And what we had said was that it's an angle, whose vertex is on the circle, and, so again, whose vertex is on the circle, and whose sides contain chords of the circle. So I think that's a pretty good definition right there. Okay? So the definition we came up with here was an angle whose vertex is on the circle and whose sides contain chords of the circle. Okay? That's really good. I think that's good. All right, so let's take a look at this inscribed angle right here. And I want to tell you something else that's important about inscribed angles, okay? So I'm going to write that again in a text box. And that is the following, okay? The measure of an inscribed angle equals 1/2 the measure of its intercepted arc. Okay. You know what? I'm going to put a space here because sometimes we end up with. Good. Okay. So the measure of an inscribed angle equals 1/2 the measure of its intercepted arc. So what does that mean here? Well, let me take some red here. Okay. So here's your inscribed angle. The measure of this angle, okay, is going to equal 1/2 the measure of this intercepted arc. This is the intercepted arc. Okay? So if we were to write that down, okay, that means that the measure of angle BAC, okay, which is this red angle right here, BAC, equals 1/2 the measure of its intercepted arc, which is arc BC. Perfect. So for example, if the measure of angle A or angle BAC were 40, let's say, then the measure of arc BC, then the measure of arc BC would equal 80. Okay? So just remember that the measure of the inscribed angle is going to equal 1/2 the measure of its intercepted arc. So if BC were 100, angle BAC would be 50. All right. Now, what I want you to know is if you want to know, I'm going to make another video where I explain why that's the case. So you can check that one out when I put it up.